Greetings, this is Artie from Artifact Electronics. In this episode we'll be revisiting this Tektronix TDS 460 scope. We looked at the scope in episode number 4, and if you haven't seen episode number 4, I'd suggest you watch it before watching this because I think things will make more sense. But we found that there was some capacitor leakage on the acquisition board and the front end board. And that got cleaned up, capacitors got changed, and eventually I found that 2 of the voltage regulators had their traces eaten through on the acquisition board. And once that was fixed, it came back to life and it worked very well. So I put it back together, and I've been using it since on the bench. I mean, I do have a better scope, but what good is it fixing all of these things if you don't use them? So I make it a habit to try to use things that got repaired as much as possible. I really enjoy this scope. It's very nicely built. It's not in color, and it has a CRT, but it's very easy to view, and its functionality is very good, especially for a scope of this age, which is, it's an early 90s scope. But what happened a few days or a few weeks ago, I should say, is that I started using it, and from one minute to the next, all of the buttons stopped to work. Everything, including the rotaries, which are essentially buttons, also. And it all happened at once. So it wasn't like, there's a dirty button, or maybe even a dirty row of buttons, or a row or a column diode has gone out. No, the buttons just all stopped to work. And after playing around with it for a bit and rebooting it, some of the buttons started to work, but very intermittently. And so it was time to have a look at the front panel board. Now, last time I looked at this, I did not pull the front panel board using the if it ain't broke, don't fix it approach. But I may have had to have a look at it. What I am suspecting is that since I saw some pretty extensive capacitor leakage on the acquisition boards, that we may find the same thing in the front panel or on the front panel board, and hopefully we'll be able to clean it up and find if it's eaten any traces or caused any discontinuities in there, and bring the scope back to life. These scopes are relatively service-friendly. Well, mechanically service-friendly, I should say, because they open up and access to the boards isn't that difficult. You take off the case, you then unsnap the front plastic bezel, which is held in place with 4 plastic tabs. Careful so you don't break the tabs. And then you can, there's a tab on the side of this that you push in, and then it swivels out and is easily removed. And once you take out, there's 4 ribbon connectors connecting it to the rest of the instrument, and it's free. So let's have a look at it now. And I hear collective gasps coming from the audience, but we'll talk about this abomination in a minute. What I found in here was that the capacitors had leaked pretty badly, and they had leaked even worse than they had leaked on the acquisition board. So things were not in good shape over here. I did a lot of cleaning up. Of course, I pulled the caps out first. I did a lot of cleaning up in here, and there was a fair amount of crud that came off. I did not, however, find any specific defects or discontinuous traces. What I did find, though, was that as I was testing it, the buttons kind of, after I cleaned it up, the buttons started to work over here, but they were still sort of intermittent. And so as I looked more and tried out things, I hooked up the probe to the calibration signal, and the calibration signal wasn't there anymore. It wasn't working at all. Now, looking at this, and again, schematics aren't available, the calibration signal goes out on this connector, and so it was the calibration signal was getting generated in this area over here. And for some reason, even though there is no capacitor electrolytic right here, the closest one is over here, this area was hit the worst. I mean, there were totally encrusted components here that I couldn't even identify. And I removed some, made some guesses, and the bottom line was I could not get the calibrator to work anymore. No matter what I did, no matter what I replaced, it just would not come back to life. But, you know, it's a calibrator, it doesn't have to be very exact, but you need a calibrator on here. What I did was I threw together a simple 555 based oscillator here that generates a square wave, and it's just got 3 wires on here, power, ground, and of course it goes to the actual calibrator connector over here. It works fine. The biggest problem for me was how do I mount this, but I ended up mounting it on these 2 rotary switch casings and gluing it into place. So now I cleaned up again, and now the buttons seem to start to work. Again, not having found any sort of a defect other than the calibrator circuit not working. And I put it back, the calibrator was working, and the buttons and the rotaries were working, everything seemed to be okay. I actually separated this from the front panel itself and went in and put contact cleaner onto all the buttons and contacts, and things just kind of started to work. But the soft buttons were the soft buttons surrounding the screen were still not working correctly, and they were intermittent. And I opened it up, and I think I cleaned like the top 2 buttons with alcohol and put them back, and that seemed to improve things a lot. So I said, all right, let's give this thing a good cleaning. And that is when disaster struck. The button that was most obstinate was the clear menu button over here, so I thought I'd give that an extra good cleaning. I didn't do anything different. I cleaned it the same way I had cleaned all the other buttons, but after 2 or 3 swipes with a Q-tip dunked in isopropyl, it took off. It made this ugly mess. It basically took off everything on the flex PCB down to the base material. So I'm looking at this, and it was really, really strange because there was no residue on the Q-tip. It just kind of, poof, made it disappear. I won't even guess what happened, but the closest thing to me is that the corrosion wandered here, and since this is probably the most used button of all of the soft buttons over here, it just reacted. Or maybe something came in, some liquid was spilled on it. I really don't know. All I know is that using alcohol essentially took everything off. And this is somewhat of an intricate design with some insulators on the sides. So this is not a simple matter of getting conductive paint and getting it back to work again. So after I stopped being angry at myself and the alcohol and the world in general, I continued looking at this and trying to figure out a plan of attack, because the one thing that I did know was I had to get the scope back into working condition. And if we look at this, basically this strip, this flex PCB is glued onto the metal frame. So of course the first thought was, wow, let's just gently remove this and buy a replacement. So gently remove it. I used an X-Acto knife to start peeling it off, and as it was peeling off, it is extremely brittle. It cracked all the way across from the corner to the bad area. I was beyond getting excited about this anymore, but yeah, it wasn't a good day. But of course I went and did some online research to see if I could buy a replacement membrane, I guess you'd call this, and then it would be a simple matter of removing the old one, regardless of whether I was going to break it and tear it. It didn't really matter. I was going to put in a new piece anyway. And so my search started. This is what showed up on my doorstep today. I found this advertised online, and it was essentially advertised as a piece of shit that didn't work right. But the small print said, I can't really give you any more detail. The screen lights up, but it is so dim, it is very difficult to read. It was only $49, and the better part was the shipping was only $16. So for $65, I got this. Of course, as usual, my gripes were that it was somewhat dirty and gross, so I spent quite a good amount of time cleaning it up, getting rid of black marker all over it and stickers and unidentified substances. As you can see, it's missing the handles, it's missing the feet. Two of the BNC connectors, it was dropped somehow. I mean, this corner is loose, and it was dropped, and they are no longer round. They're more elliptical than round, and you can't even plug a BNC connector into them. Not a big deal. They can be replaced. And you can't really see it in the video, but there's a lot of residue on the control panel over here. And but other than that, I did boot it up, and the seller wasn't lying. The screen was super dim. I mean, it did come up, it did boot up and give me an error report, but it was so dim I could make out that there was an error report, but I couldn't really tell what it said. So using the knowledge I have from my 460, I navigated the menus to the screen intensity, and I could make out that the screen intensity was set really, really, really low. So I cranked up the screen intensity, the trace, and the grid and everything. And it turned out that it had a beautiful screen, beautiful, sharp screen. It came up, so I rebooted it. And pretty much anything that was related to the acquisition boards, front-end acquisition boards, was tagged as failing. And I was able to plug in a probe into channel 1, and yes, it was not doing anything. But so here's a scope. The front panel works, so I have to go in and check all of the low voltages, but the CRT is good on it. And so the big if was, what does the front panel membrane look like? The case was bent pretty severely. It took me quite a bit of time to get it to slide off. This thing had been dropped several times, and it showed. But it opened up, and the nice thing is it's got a beautiful soft key membrane on it, and since it ran, I already saw it running. That should be our new membrane. Of course, I also took off the front panel board, and surprisingly, this doesn't show any corrosion. The caps are good. Oh, and I also tested the calibration circuit, and that works too. Now, of course, the astute observer may have noticed that I left out a big part here, and that is, this is not a 460, but rather a 420. Now, my logic behind it was, of course, this was the cheapest I found. And second of all, since I'm only interested in the membrane, and also interested in the front panel board, and this one just seems to have no corrosion on it, so this one's plug and play. Is it going to work? It's total guesswork at this point, but I'm pretty sure that it will work, because the functionality of the scope is the same. The 460 has a higher bandwidth, but other than that, everything's the same. So the acquisition boards are going to be different, the firmware on the processor board is going to be different, and all of that. But the parts that I really need should be compatible. The only other thing is, as I mentioned before, there's a lot of tape residue on here. And but other than that, the only difference is that the help over here is in gray, and for the 460, the help is in orange over here. But since this clean, the 460 front panel is really clean, I'm probably going to use this front panel and transplant it over to this assembly. And that, of course, brings us back to the rest of the instrument, which it isn't really that interesting because I've decided to use it as a donor. But again, there was, even though the acquisition boards have a problem, there was very little capacitor corrosion. There is some on the acquisition board and the front end board, but not nearly as much as I saw on the 460. Of course, for the 460, those boards are useless because they're not going to be fast enough. But I think this one, the scope lived a healthier life as far as capacitors were concerned. So let's come up with a plan of attack. Originally, I was thinking I'm going to have to tear everything out of this and end up with a naked frame with the membrane on, and then transplant everything from the 460 to it, except, of course, the front panel board itself. But since this came up and the screen's beautiful on it, I did some power supply measurements, and they're all good. So essentially, the power supply and the CRT are not going to have to get transplanted. What I do have to transplant, of course, is the front end board. And I have to transplant the front end board anyway because these BNC connectors are bent and won't accept any BNC cables. The acquisition board itself, which is underneath here, and the CPU board, the DSP board, and one other board that is in the card cage. I'm not going to risk mixing and matching those, but rather I'm going to replace all of those, and then we'll power it up and see if we have magically transformed this frame into a 460 with working buttons. Here's the bottom of the 420. I've started removing a bunch of connectors and screws and everything. But I think the most important part of this is to clearly label the boards as to what they are. There's lots of numbers on them, but none of them are easily identifiable as 420 or 460. So this way, if a bunch of boards get removed and they end up in a pile, I won't be sitting there forever wondering if I've got the correct boards inserted. This, of course, is the acquisition board. And one thing you'll see is the main repair I did on the 460 was on the two voltage regulators over here, which had lost connectivity over here. But this, and again you can see this does not have any capacitor leakage on it, but obviously there's something else blown up on here that keeps making the scope complain about it. So here's a 420 parts board. There are 5 or 6 screws that hold the board to the top of the frame. There's a wire soldered to a BNC connector on the back. There is these flex connectors which you have to remove and very carefully thread through the slot in the board. And there's also a header connector over here that connects to the rest of the boards. All of those removed, and it came out. Another nice thing was that the case was bent, and showing that the instrument was dropped or mishandled in some way or other. But fortunately, the case, the actual frame, is in good shape. There's no bends, there's no damage, there's no corner dings on it. So this should work out very well. Next, we have the front end board. Things are mostly removed from here. One more screw remaining. I have also removed the flex connector over here. Everything looks good in here. The caps look pretty clean, and it's a shame that something is wrong with this set of boards, but something to worry about some other time. But again, this is also labeled, and this definitely looks cleaner than the 460 board. I mean, I wish I could use this, but I do not know what the differences between the boards are, giving the 460 the extra bandwidth, so I'm not going to try to reuse this board. And with that gone, the bottom of the case is clear, and it's ready to accept the 460 boards now. Took a bit of manipulating to get this to come through in one piece, but it's not torn or bent. And basically place it on the connector and gently push it into place, making sure that none of the pins got bent. And of course then we have our assortment of screws that need to go in to hold this in place. And not to forget, we also have this wire that needs to be soldered back. And the next candidate is the 460 front end, and kind of hurts me to have to put this back in because of the corrosion over here, but it was cleaned so many times and it has survived many hours of work, so I think I got this one. So we should be good. And of course, best of all, the BNC connectors are straight on this, and all except BNC cables. So this one will go a lot easier. It doesn't have a slot for the flex connector, but it just slides in, and also has, of course, an assortment of screws that hold it in place. And one of them, by the way, is hidden under here, so if you're doing this and you're wondering where it went to, it is well hidden. So let's put this one back. And I'll continue fastening this. And then we'll have a look at the cards in the card cage. Okay, everything's screwed in. Let's make sure that everything is there. This board is held down with 5 screws. No, 1, 2, 3, 4, 5, 6 screws. This connector has to be soldered back to the board, and I don't recall what that connects. Oh, that's the auxiliary trigger input over here. This one got plugged in. For the front end board, This one got plugged in, and this is held in place from the top with 4 screws, these 3 and one right underneath here. This also takes additional screws in front for the probe auto detection PCB, and we will get to that, but let's try and see or replace the boards in the card cage. More boards to pull. So first let's get rid of the header plug. And start with the lowermost board, which I've loosened. So it's got a plug going to the front panel. And a battery plug. Now that board, the board we just removed, is has a 68020 on it and lots of flash ROM. So I bet you this is the this is what execute the main OS, and that would be what computer code wise distinguishes the 420 from the 460. Next, we take out this guy. It has the ribbon cable connecting it to the power supply. And this seems to be doing, has 2 ADG 221s on there. Well, it's a 221 and a 222B, but it's a VLSI chip, so along with a TMS 34061, which is a display processor, and that's because this is the VGA board. Probably no need to swap this, but since we're at it, we might as well take this out. And last but not least, we have this board that has a National ADG 500B on it, and lots of nickel and dime parts, and it is also connected to its own battery, so this has 2 batteries in it. Alright, those 3 boards are back in and screwed into place, and of course as I put it back I realized there's 2 batteries in here, and I should probably measure them. Now they're really well insulated. It's like impossible to measure them anywhere other than actually on the board. So the first one's easy because the board connector is, you can't see it. Anyway, the board connector is on the other side of the board over here, and let's see what this reads. 3.1, which is plenty, and this one's a little bit more difficult to get to and even more difficult to show, so just have to take on faith that I'm actually measuring the battery here. And that one is, what did I see, 2.9. So the batteries still have plenty of power. If they lasted this long, they'll last for a good long time longer, I think. So we are good there. So what do we have so far is we have all of the card cage cards back in. We are going to need to reinsert the inner board connectors here. And where did you go to? Here they are. Is that the right side, right orientation? Yes, it is. First one. Second, and third. So all of these guys are connected together now. Another thing I want to do is, with the luck I've been having lately, I'm going to remove all of the tape I put on here. And that's because with my luck I got tape on this large chip over here, and it's probably going to cause some thermal abnormality that'll make the chip blow up. So I'm going to give this no excuse to fail on me. So all of the tape comes off. So at this point, all of the board swapping is done, and what is left for us to do is the front panel. So for the front panel, what we're going to do is, here is the 420's front panel, and the front panel is kind of dirty and tape and everything on it, so, but the electronics are good in here. So what I'm going to do is use the electronics in here, but transplant this front panel from the original 460 over to here. So everything will look just great. And now for the front panel, what we got to do here is do the faceplate transfer. I'm going to use, this is a 420, I'm going to use everything in here except the actual faceplate because there's a bunch of tape residue in here, and it doesn't exactly match the 460's panel, mainly because of the test legend here is red on the 460, and also the shade of gray used here is different. So anyway, let's open this one up. Not open it up, but let's separate it. And the way to do that is, first we have to remove all of the protruding buttons. And the service manual gives you this procedure where you're supposed to stick screwdrivers underneath the button here and lift it. And well, if I do that kind of stuff, I'm just going to scratch the front panel, tape residue or not. And what I found is easier to do is you just turn it around and press the buttons through from here with a flat surface like a flat-bladed screwdriver, with no damage or no risk of damage to the front panel. And these two, my fingers are sticking to the front. Well, these can probably just push through by finger, but no, it's too much of a hassle. I'm trying to be careful here. I really don't want to break anything. So let's try this. And there we go. The buttons are out, and in order to separate the PCB from the panel there are more tabs, more plastic tabs. One here, one here, and one right in the middle. And you lift it and gently pry the board off. So we want to keep this board. This is our final board. Probably want to keep the membrane layer. And since this worked so well, we might as well keep the rotary inserts here, if they're going to come out easy, and they are. And then we'll just do the whole thing in reverse using the original 460 front panel. I can't turn it because all the buttons will fall out, but we'll just reassemble everything in here. And it seems easy enough. I could do that here. Let's remove the rotary inserts here. Put the old ones back in. They're actually... There's a ball bearing in there, which seems to match up with that. And another one, which matches up like that. So now we need to put back the membrane, right side up, hopefully. And followed by the PCB that should just snap back in. One click, two, and that's already clicked in. So here is our repaired 460 front panel. Make sure that all the buttons travel freely, and insert the knobs. Well, this one doesn't want to go in, so let me figure that one out. Alright, misunderstanding between me and the panel resolved. We got these in, and that is followed by one more. And we're done. Old face, new electronics. Okay, straighten things out a bit. So this is a lot better looking and more confidence instilling than this, obviously. So, alright, next step is to set this up right side up. And put all the connectors back in. And we need this too. This of course goes right here. Wait a minute. Oh, I haven't inserted all the screws. Click. That's in place. Now, for this stuff, this one's nice and long. So is this one. And of course, this is the spare part that it was all about. Now, put in the inputs. And finally, we are left with this one. And that fits into place. Hinge this in and press it into place. Now we need some screws to hold down the input panel. And I will make a final pass through and make sure that all of the screws are inserted. Well, in this case we're going to install the front plastic bezel, so I better make sure that these screws are all in. And they are. Now let's get the plastic bezel. Preferably the right one that says 460 on it. And it has the membrane inside. And it's also held in place with tabs. Okay. I had to spend some time with the front bezel again. It didn't want to snap into place. Every time I pressed things into place, they would go in, and the minute I let go, they would pop back out again. So I removed it and went for a few rounds with it, and finally I had things just aligned perfectly, and it snapped into place. One other thing I did was the workbench was getting rather messy at this point, so I decided to do a little bit of cleanup, and that is the remainder, or the remaining parts of the front panel were all over the desk, and I decided to put this back together again. And not that I'm going to use this in its entirety, but here's my parts front panel for the TDS series. And I found a few more odds and ends on the workbench. First ones were these guys, which are board brackets that hold boards in place and align them properly, I guess. So let's see where that goes. That goes in here. And this one goes in here. It doesn't want to click. It clicks when it comes out, but not there. It was kind of a half-assed click, but it did go in. And finally, this one. That one went in nicely. And I think something a lot more important than this that I found is the interconnect between the acquisition board and the front end board. That wouldn't have worked too well without it. This one is properly labeled 460. Doesn't really matter because it's a passive interconnect board, and even the numbers match to the 420s, but let's keep things consistent. And with that said and done, everything is in place. I don't see any extra pieces flying around. So let's put this into position for the final test. I went ahead and double checked some more. Would be kind of a shame if I turned it on and I went up in magic smoke. Just to catch some obvious or stupid mistakes, but couldn't find any. I couldn't find any smart mistakes either, so no more procrastination. Let's take a power cord. And see what happens. Power switch on the back is on. And lift off, or countdown I should say. Fans running. Lights are on. The screen's obviously working. Oh, this is great. Let's see if it makes the galloping sound testing the acquisition board. Right on cue. That's good. Lights went off. Things are running. And boom. Self-check passed. Fantastic. So let's see if we can adjust the screen brightness a little bit at this point. And of course for that, we'll put some text on the screen. And we go to intensity. And overall intensity is at 90%. Let's crank that a bit. I'm going to crank that to 95. Text in the graticule. We'll leave that at 75. A little less than that. We don't need that much. 65. And the waveform itself, we'll leave that at 70. And the button works. Fantastic. We gotta put the case back on and give it some input. But it looks as if the board transplant was successful, and that at least my beloved 460 is back in full health. I mean, I gotta walk through all the buttons and turn all of the knobs with the signals applied to it. But if it continues performing like this, I guess that will be the fun part. One more thing to note is when putting the case back on, since we had removed the front bezel, these pieces of the EMI shield all came out, and they need to be reinserted into the channel. And these actually do a really good job of reducing extraneous noise. It's a bit fiddly to put them back in, but it's well worth it. There's 4 pieces, and you can normally see from the wire memory where they belong. And again, you just put them in and press them down into place. And once you put the case on, it'll make contact with that. And again, you only need to do this after having removed the front bezel, because when you remove the case, these generally don't come out. Okay, looks like we're back in business. I did run a calibration cycle on it. I'm not showing it because it's kind of boring to watch. The screen goes dim and there's all sorts of things happening on the screen that aren't very interesting to watch, but what that did is basically made sure that the reference levels, these little arrows over here, match exactly where the signal is. And the signal looks a bit noisy right now, so what we can do is go to the Acquire menu and tell it to use a high-res display, and that gives us a nice analog looking straight line in here. So let's see what our compensation signal looks like. And there's our compensation signal and the little indicator showing us where it's triggering from. You can turn that off if it becomes annoying. But there's channel 1 for you. We then move on to channel 2. Turn off 1, turn on 2, and let the scope do the work for us by pressing auto set. And there's channel 2. We'll go to 3, turn off 2, turn on 3. It's almost there, but we'll let it auto set itself. That's probably because the trigger source was still set to 2, and it couldn't trigger properly for channel 3 because there was nothing on 2. And finally, we'll go to channel 4, turn 3 off, 4 on, with kind of the same results. We don't even have to auto set this. We can just go to the trigger menu and set the source to channel 4. And everything looks great. Let's measure the signal coming out, and let's do frequency and a peak to peak, which is here. So it's very close to 1 kilohertz, which it's supposed to be, and peak to peak's 520 mils, which is a little higher than specified, but it's nice to see that the original calibrator circuit is working in here. And this was by no means an in-depth test, but it does show that it's pretty functional. And since I'll be able to use this on my bench again from now on, time will tell if everything else works. Well, thanks for watching, and I hope you enjoyed this at least a little bit as much as I did after seeing the scope come back up again. It was, I was pretty angry at circumstances when the thing went, when those contact traces disappeared, but nothing that time and money can't fix, right? Well, go ahead and if you like it, give me a thumbs up. And if you haven't already subscribed, go ahead and subscribe. There'll be lots more stuff like this coming up. See you later.